So in level 2, two types of oxidation reaction we need to be aware of. Alcohols, they can be oxidized, the OH functional group in alcohols can be oxidized to a carboxylic acid functional group, or a COOH functional group, and if we have alkenes, they can be oxidized to diols. Diols is when we have two OH functional groups attached to one molecule. Let's have a look at these examples here. So the first one I have here is propan 1-ol. So we can see that from the OH functional group attached to the first carbon, this is an alcohol. If we add the reagent permanganate and it's acidified, so MnO4- H+ means it's acidified. Sometimes this is written as KMnO4 /H+. So what this will do is the permanganate actually gets reduced, but we don't need to worry about this when we're writing organic chemistry reactions. But the carbon that the OH is attached to becomes or gains a double bond oxygen and keeps the OH group, and it forms a carboxylic acid functional group. Now, actually, at this level, we don't need to know this, but there is an intermediate that happens along the way that's called an aldehyde, but this is the end product, carboxylic acid from an alcohol. Now, so we can use this acidified permanganate, I said. Now, if we do use this acidified permanganate is actually a purple color, and as the reaction proceeds, the purple color will become colorless. It produces manganese ion, which is colorless, and you will notice that this reaction will go from purple to colorless when you heat it. Okay, so the next type of oxidation, well, the same type of oxidation reaction but a different reagent, is we can add to an alcohol so these are, just to be clarify here, these are both primary alcohols because the alcohol group is attached to a carbon that is itself only bonded to one other carbon. So if we oxidize a primary alcohol here, what we can use acidified dichromate. Now dichromate is Cr2O72-. H+ means it's acidified, and if we do that, we can again change the alcohol group into a carboxylic acid functional group. But in this case, the reaction has a slightly different observation. It will start as an orange color and it will proceed to green. The dichromate will turn into a chromium ion, Cr3+, and it is a green color. And these will actually be used later to identify the presence of primary alcohols. Now we have another type of oxidation reaction, and that is when alcohols get oxidized. Now when alkenes get oxidized. An alkene is carbons with a double bond, okay, between them. And when we add permanganate, and now it doesn't have to be acidified. Sometimes you'll see in Grecians they write down that it's acidified. It doesn't have to be. We're just adding MnO4-, and what happens is the double bond breaks and we add an alcohol group to the carbon where the double bond broke, an alcohol group to each of the carbons. So we produce what's called a diol. Okay, so we change from an alkene to a diol. This is another type of reaction that can be used to identify this species, because if you add permanganate to an alkene, actually this turns into manganese dioxide, which means that this molecule will go from being purple to being brown. And these are the types of oxidation reactions we need to know for organic chemistry. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.